Okay, so just wanted to take a few minutes and talk about these problems from last week. I know I released a key to you, but there's some things that I want to make sure I point out on some of these problems that are very common mistakes. So we're going to go through these pretty quickly. I already have them all graphed, and we can identify the easy roots and then go from there. Okay, so I have the first one already graphed, ready to go. And you can see that our nice root has been identified as 1, 0. So our root is actually x equals 1, which you could write as an ordered pair, and some of you were doing that, and that's perfectly acceptable. The factor itself, though, is what would be in the polynomial so that when I set the factor equal to 0 and solve for x, I get 1. That would have to be x minus 1. So now I can actually begin the division. So I'm going to quickly set up my division box here. Notice I'm not, being super careful, drawing all the lines really nicely. I'm just doing this so that I have a way to actually do the division. My polynomial that I'm dividing by goes along the bottom. And then what I'm using as my factor, which is what we have here, gets written along the side. And then to start the whole process, remember, I put the leading term, the highest powered term there. And then I start the process. So I ask myself, what am I going to multiply x by to get x cubed? And that's what we'll write here. And that's x squared. And then once you've written that top part of the box, x squared times everything else in my factor, so x squared times -1 gives me -1 x squared. Now what I know is that these two boxes have to add up to 3x squared, which means this has to be 4x squared. So then I can start to think about, all right, well, what do I multiply? Again, what do I multiply x by to get 4x squared? And we know that's going to be 4x. And then multiply everything else. 4x times -1 is -4x. And remember, these two boxes are going to have to add up to 1x, which means this has to be 5x. And then we ask ourselves again, what times x gives me 5x? And that's going to be 5. Multiply it out. And we don't have to do anything. Remember, that very last box is your remainder. You want it to be 0. So it's good. We know that x minus 1 actually divides into our original polynomial nicely. So now I'm going to take this polynomial that I have written here, and its highest power is squared, which means I can now actually go through and use the quadratic formula to find the remaining roots. Now, I know some of you probably tried to factor this, and that's fine, but it won't factor. So at this point, I would use the quadratic formula. I'm not going to go through that whole process. If you want, you can use the notes to see what I did there, or the answer key that I sent you to see what I did there, but it's just the quadratic formula. So when you use the quadratic formula, you get this. Now here's where some of you maybe got a little confused. We need to simplify this a little bit. So we need to use our knowledge of imaginary numbers now and simplify the square root of -4 to be just 2i. And then we can actually simplify that a little bit more because we can divide. You can think of this as -4/2 plus or minus 2i over 2. In other words, all three of these terms are divided by 2. Okay, so we end up with -2 plus or minus I. So our two roots are -2 plus I and -2 minus I. So to wrap that all up, our roots are positive 1, -2 plus I, -2 minus I. And then when we write this in factored form, we need to write this as, and I don't want to use that equals 0 there. We're just going to have this equal to f of x. We don't have rational roots that came from this quadratic. So that is our factor, okay? So the only way we actually would write these things that we found here is if they are rational, real roots, okay? So we don't have to write it as x minus -2 plus I and x minus -2 minus I. All right, so for this problem, a lot of you tried this one, but you actually made it harder than it needed to be. Some of you went ahead and figured out that your nice roots were on your graph, and actually all 4 roots were able to be found by just looking at the graph. And you just saw these as being your nice roots because they were integers. And so you went ahead and wrote your nice factors here. However, and then went through the division and finding that highest powered quadratic and then using the quadratic formula, when in reality, you actually have your roots written here. So our roots we know are x plus 3 and x minus 2 to start. And to get the remaining roots, we have to think about to get 1/2, or to get -1/2, I'm sorry. So if we wanted to end up with -1/2 as our root, work backwards, okay? So let's add the 1/2 to both sides. And the reason I'm doing that is, actually, let me do this another way. Let's multiply both sides by 2. All right, and then let's add 1 to both sides. Now, when I do that, what I'm ending up doing is I'm putting the factor equal to 0. This is my factor, 2x minus 1. And we could do the same thing with x equals 1/3. Now, hopefully you guys realized 0.33333 repeating is just 1/3. I'm going to multiply both sides by 3 and subtract 1. That gives me roots that are, sorry, that's plus 1, that are not written like this. Okay, we don't typically see roots in our polynomial written that way. So that's a little more standard. And that's why I wanted to show you this one, because that's actually the way we would write the factors. So I'm just doing this above where the answers would go. That would be our factored form, and then our roots would be these, and you could write 1/3 or -1/2 as well. So the interesting thing about this one is that the root that you can find on your graph is a bounce, and we've talked about these in previous lessons. It's a bounce, which actually means that that factor will show up twice, or in your factored form of your polynomial, you'll see a 2 as a power for it. So what that tells you is you're going to have to go through and actually find, do the division with that same factor 2 times. So the first time, we have x plus 1, and our original polynomial of x to the 4th, plus 2x cubed plus 10x squared plus 18x plus 9. Let me draw all the lines in here. And we're going to figure out what our polynomial will look like after we do that division. Now, if I work through this pretty quickly, I know that 2x times x will give me, oops, I started with the wrong thing there. I need to start with x to the 4th. So let me do that again. So this is x to the 4th. So I know that x cubed times x to the 4th, or times x will give me x to the 4th. These two have to add up to 2x cubed, which means this has to be x cubed. I know that x squared times x will give me x cubed. Then I get x squared. These two have to add up to 10x squared, so that's 9x squared. And again, this is all on the paper I gave you, and that's why I'm working through this pretty quickly here. These two are going to add up to 18x, so that should be 9. And then finally back to the top here, so this is going to be 9 times 9. Our remainder is 0. So the reason I want to show you all that is we take that polynomial that we've just now written up top there, the colorful polynomial, okay? Now that's going to become the new thing that we divide by, or that we're dividing. So x cubed, I don't really need that all the way through there, plus x squared plus 9x plus 9. So I'm taking my answer from that previous division, and now I'm using that with x plus 1 again. Okay, so I'm going to pause the video and go ahead and finish that, and we'll come back and finish the problem. Okay, so we end up with this quadratic, and that's our goal, to get something with the highest power of 2 that we have to solve. You could try to factor this, but you're not going to be able to, because it's not a difference of squares. It's a sum of squares, and we don't have any way to factor that. So you could use the quadratic formula, which is fine, or you could subtract, you could undo, right? I mean, we've talked about this before. We could undo on both sides. You get x squared equals -9. And then when you take the square root of both sides, you get the square root of -9. Now, again, knowing what we know now about imaginary numbers, we should be able to simplify that. And then to finish up, again, writing out what our roots are. We know that -1 is used twice, which when we look at, what our roots are. And then when we look at the actual factored form of this, we know that means that that factor will have a squared on it. And then since these are not real rational roots, we can just write our factored form as x squared plus 9. And I don't remember which polynomial this was, maybe h of x, but that's how I would write this in factored form. Okay, so initially when you looked at this, you probably thought, well, Mrs. Kopp, this is kind of tricky because it looks like I'm only going to have, and I didn't label this one, 2 nice roots. This is actually the 0.50. So we're going to have really, there's 4 nice roots here. And the reason that is because this right here, it's sliding through that root. Remember, we said that when you have a slide in a polynomial, it almost looks like a cubic graph right around that root. And we can see that cubic shape in the graph right there. If we had just looked at that part of the graph, it looks like a cubic graph. That indicates that that root is a triple root, which means that it'll have a 3 at the least. It could have a higher powered odd root, but we're going to start with 3 and then look at the fact that this other root that shows up on our graph, when combined with the 3 here, give us a total of 4 roots. And we know that our highest power, our degree of this polynomial is 4. So we know that at most there can be 4 roots. So we have now located all of the roots. And then to write this in factored form, I would just have x minus 1 cubed times x minus 5, and I'm done. No need to do any polynomial division on this one. All right, so this one was interesting in a lot of ways. First of all, initially looking at the graph itself, you might have seen, okay, there's 1 root, there's 2 roots, there's 3 roots. Maybe here at 1, you said, that looks a little bit like a slide. But here's the deal, guys. It does look a little bit like a slide. But if you're not sure, don't assume. So I'm going to assume that it is not a slide and work from there, which means I'm going to have to do some polynomial division. Now, this is the reason why this problem I find to be interesting. Okay, so we have x to the 5th. Let's write our polynomial out. But here's the problem, and this is why it's interesting. We go from a 5th power to a 3rd power. So we have to hold the place for that 4th power with a 0. And I'm wagering that if you had problems with this one, that would be why. And we also then have to hold the place for the x term as well, because there's no 1st power. Now we've got it set up, ready to go. We can do our polynomial division. I'm going to pause the video, fill this in. If you aren't sure, make sure you ask questions, but you can come back and check. All right, so it should look like this. If you had any issues with this, please make sure you post a question. Now, I have to then take what I've just found as my polynomial, and I'm going to divide by the next one that I wrote down. So the question some of you may have had at this point is, what happens if I started with something other than x plus 2 here? Guys, the thing is, you're going to end up in the same place, but those steps along the way might look a little bit different. So if you had started with x minus 2, you're going to get a different polynomial here. But you still have to divide by these 2 things. And by the time we get down to our quadratic, we should all have the same quadratic. Okay, so I'm going to go ahead and pause the video, divide by my other 2 factors, and then you can come back and we can compare our quadratic. All right, so we end up with our quadratic down here of x squared plus 1x plus 1. And then from there we can find Our roots, again, you can try to factor it, but you're not going to be able to using the quadratic formula. I don't think I need to go over the quadratic formula, so I'll pause the video, kind of show you where you may have gotten stuck in that process, and then we'll finish. So if you use the quadratic formula, you probably got to this point where you simplified some things and you ended up with, again, a square root of a negative number. So our knowledge of imaginary numbers allows us to finish this, but the question is, you can't take the square root of 3 and get a nice rational number. So we'll just think of this as I times the square root of 3 over 2. So now we've got our remaining 2 roots. And then finally we have our list of all the roots and how we would write this in factored form. Once again, because this quadratic leads us to imaginary roots, we just write that quadratic as our factor. So despite the fact that most of you probably thought you could jump right to the answers here, this is for sure a nice root. 2.646, probably not. I don't know about you, but I can't think of any fraction that would give me that as an answer if I were to divide it out. It's not rational. Okay, so in order to find the other roots, I am going to have to go through my division process. So we'll do division with the x plus 1 factor, and then we'll see at that point we should have a quadratic that we can go ahead and use quadratic formula or factoring with. So I'm again not going to go through this whole process once more. If you want to, you can try it on your own and then pause the video and come back and see how you did. So what we end up with as a quadratic is just x squared minus 7, and we have to solve that just like we would any other quadratic. Once again, we could use the quadratic formula here, or we could just undo. Add 7 to both sides and take the square root of both sides. Now, the good news is there's no imaginary answers here. There's no imaginary roots. These are all real roots. The bad news is they're still irrational. So when we go to write our answers out, our roots are just x equals -1 and then plus or minus radical 7. In factored form, once again, that's going to be x plus 1, and then it's going to be x squared minus 7 equals, I think this is k of x maybe, or L of x, I don't remember. Once again, we write that as a quadratic for the factor because it doesn't give us rational roots. Okay, hopefully this helps. I'm going to have you try a couple more of these this week, and then we'll do a little bit more with some systems of equations in the next series.